Good day, everyone. So our topic is about amine. So I am Dr. Irving R. Abrencillo. So for our learning outcomes, first describe the properties of amine or amine. Determine the steps in writing a correct chemical name and formula of amine. Name and create chemical structures of amine. So amines and amides are abundant in nature. So the amide will be discussed a little bit later. So they are a major component of proteins and enzymes, nucleic acids, alkaloid drugs, and others. So alkaloids are N containing weakly basic organic compounds. Thousands of these substances are known. Amines are organic derivatives of ammonia or NH3 in which one or more of the three H's are replaced by a carbon group. So that's why we have different classifications of amines. We have primary, this one, with only one attached R. So it could be an alkene, an alkyl. We also have secondary here. We have two attached. And then tertiary, wherein all the possible attachments are attached to the end. Okay, so with that, can be able to look into the properties of amines. So nitrogen is less electronegative than oxygen. So the NH bond is not quite as polar as the OH bond. If you will remember in the previous discussion, like that in the carboxylic acid, it has a strong polar structure. So because of the OH bond. Now in here, we have NH bond. So hydrogen bonds from NH are not as strong as those resulting from the OH group. So hydrogen bonding between primary and secondary amines is not as strong as those found in alcohols or carboxylic acid. So primary and secondary amines have lower boiling point than alcohols of similar molecular weight because of that explanation a while ago. So tertiary amines, since they do not hydrogen bond to each other, have boiling point similar to hydrocarbons of the same molecular weight. So primary, secondary, and tertiary amines can all form hydrogen bonds with water. So low molecular weight amines are generally water soluble. So these low molecular weight amines are those with lower number of carbon. So low molecular weight amines tend to have sharp, penetrating odor similar to ammonia. So you can easily distinguish the amines because of their smell and as low, especially those with low molecular weight or those with lower number of carbon. So higher molecular weight amines have often smell like rotting fish and are often found in decaying animal tissues. So whenever you smell decaying animal tissues, let's say, for example, a decaying body of a mouse uh, in your ceiling or on the floor or in any storage, so that is the amines that you are smelling. So let us look into the nomenclature. So simple primary, secondary, and tertiary amines, common trivial names or what we call as the common names. By alphabetically arranging the names of the alkyl substituents on the nitrogen and adding the suffix amine. So like for example, ethyl, methyl, amine. So amines in the impact system. So the E ending of the alkane name for the longest chain is replaced with amine. Like in methanamine, ethanamine, propanamine, butanamine, pentanamine, hexanamine, and so on. So the amine group is located by the position number. So groups that are attached to the nitrogen atom are located using N. So unlike the previous discussion about the Barring's functional group, only in amine and amides wherein you'll notice that you can use the letter N to tell the position of the substituent instead of writing 1, 2, or 3, indicating the position of the carbon. In this case, N is the position of the nitrogen. More complex primary amines are named with NH2 as the amino substituent. So in case of aromatic amines, so named as derivatives of the parent compound is known as aniline. So it is a benzene with NH2 is known as aniline. Substituents attached to the nitrogen are indicating by using N as the location number. So these are some examples on how to name amine. This one is the one on the left are both primary. So you have there ethyl amine. The other one is phenyl amine, or known as aniline. The one on the right is a symmetrical amine. In case of symmetrical, in all sides, they are the same. So you will no longer write the position of the carb of the alkyl substituent. So you'll just write there trimethyl amine. On the other side is dimethylamine. So remember that these are used in primary, and these are used when there are no substituents and when they are also symmetrical. Now, in case of tertiary amines, we have this way of naming. So again, you have to locate the longest possible chain. So this example, we have N,N-dimethyl butylamine. So you have here wait. We have here one, two, three, four. Okay, so you have here butyl, and then you have here NN dimethyl. So NN dimethyl butyl amine. On the other side, you have here N-ethyl, that is N-ethyl, alphabetized, then cyclohexylamine. So cyclohexyl, then the word amine. The other side, we have also this one, two, three, four, butyl amine. So you have here N-ethyl, this is N-ethyl, N-ethyl, then 2-methyl, 2-methyl. One is found in N, one is found on the second carbon. This is 1, 2, 3, 4. That's why it is N, 2 dimethyl butyl amine. On this side, we have N-cyclopropyl. So this is the cyclopropyl, N-methyl, and then cyclohexylamine. This one, right? So that ends my discussion. So I hope that you have learned something about amines.